Starting 8.1, starting with similar figures, you're going to fill it in with this definition below. Similar figures have the same shape but are proportional in size. So if you've ever seen a model literally anything, they're proportional to the original shape, meaning everyone sees how much room this wheel takes of the original car. This one is proportional. This wheel is proportional to that wheel, meaning this wheel doesn't take up half the car because in the original it did not take up half the car. All right, and then you got these little triangles that are proportional. A lot of things are proportional in this picture. But same shapes, they've either been enlarged by a scale factor or they've been reduced by a scale factor. The other thing you need to write down is the symbol. It is a squiggle. Just a simple squiggle. So if you want to write that off to the side, that means similar. Someone in first period was like, I thought that was congruent. What does congruent look like? Yeah, squiggle sign and then an equal under it. So just know the difference because we're going to describe the difference in that box below. Starting with similar polygons, go ahead and highlight this statement here. We call this the similarity statement. Similarity statement. And it states that this triangle is similar to this triangle. That's all that means, is a similarity statement. So if I asked you to make one, you would say triangle blah blah is similar to triangle blah blah. All right, so here's what we know about similar polygons, and you can kind of see it in the picture. Let's talk about their angles. So if we notice, what does angle L correspond with? Angle P, what do we notice about them? They're congruent. What M corresponds with? Q, what do we notice about them? They're congruent. So what we know is that corresponding angles are congruent in similar figures. So go and write that down. Corresponding angles are congruent. Corresponding angles are congruent. But the sides are not congruent, right? You don't have to write that down. We're going to write down what they are. What side does LN correspond with? PR. And what side does LM correspond with? PQ. And then MN corresponds with QR. This shape got larger, right? So we said they get larger by a scale factor. Okay? So what scale factor was used by each side? 2. Each side was multiplied times 2. We call this being proportional, which we'll talk about in a second. Corresponding sides are proportional. Corresponding sides are proportional. This just means we use the same scale factor. Same scale factor, which in this case was 2. Each side was multiplied by 2, which made them all get larger the same amount. Whereas congruent polygons, we'll speed through this part really quick. What do we know about the angles in congruent polygons? What does congruent mean? Same what? Length and same measure. So what do we know about the angles in a congruent polygon? They're congruent. And then what do we know about the sides in a congruent polygon? They're congruent. So you can write the sides, the corresponding sides and angles are congruent. You can combine them. Corresponding sides and angles are congruent. So a side's congruent to a side, an angle's congruent to an angle. That's what makes a congruent polygon congruent. It's the same shape twice. Whereas similar, one has gone larger or smaller. But the angles in both of them are congruent. The sides, however, are proportional in a similar polygon, but congruent in a congruent polygon. That's it for that. We're going to talk about scale factor, which you see below. If you're going from a bigger shape to a smaller shape, your scale factor needs to be less than 1, which you can write as a symbol less than 1. And then to go from a smaller to a larger, it's going to be greater than 1. This could still look like a fraction, just for an improper one. There are two ways to do this. The simplest way, you can actually take the new length over the old length, and that's the scale factor. That's the simplest way. Put the new over the old. So in this first one, what is the new side length? 4, and the old one is? This reduces to 2/3, which means I had to multiply 6 times 2/3 to get the number 4. You can do it the way we did it last semester, where you say 6 times the scale factor, which we don't know, so we call it x, gives me a length of 4, divide by 6, you still get 2/3. Both are the same. In the second, let's pick a side length. We have 4. What does 4 correspond with? 8. So you can probably see what the scale factor is. It is 2. But if you did it this way, the new length is 8, the old length is 4. This reduces to 2, all the same. So my scale factor is greater than 1 when we want our shape to get larger. When you're ready, you can turn the page. We're not doing all of this all at once, just so you know. Statement of proportionality. Go ahead and highlight this. This concept is really, really not difficult, but students don't remember what it's asking for when it comes to a test. So what it's asking for is for you to show the sides are proportional. You're going to do that by writing a proportion. How many side lengths are on each of these? How many sides are there? There's 4 on each of them, okay? A proportion looks like a fraction equal to a fraction. You remember that? So you're going to show that all 4 sides are proportional. We're going to have a fraction, a fraction, a fraction, and a fraction. I'll show you what it looks like here in a second if you want to set it up. Pick a side off of my first shape. DC, sounds good. So DC over, what side does DC correspond with? ZY. The ratio of DC over ZY is equal to the ratio, pick another side length off of the shape of DC. Pick another side. Which one? AB. AB corresponds with what side on the other shape? WX. All right, pick another side off of our first shape. AD, which corresponds with ADWZ. And then last, we have BC left, which corresponds with XY. So this is a statement of proportionality. It shows that all of them are proportional. I'll show you how in a second. But if you notice, where did all of the top side lengths come from? The first shape, the same shape. And all the bottom came from the same shape. It has to look like that. And then the second thing is that what does A correspond with on the other shape? W. We know because they're congruent. So anytime you see an A, W needs to be corresponding with it below or above. Does that make sense? So the order of the letters does matter in that fashion. We have a question about the statement of proportionality. Perfect. We're just going to practice. This asks for all of the things that we just talked about. The first thing we're going to do is find the scale factor. We're going from JKL to PQR. So we're going to find the scale factor. So from JKL to PQR. So pick a pair of corresponding side lengths. Pick a side length from JKL. KL, which is 4. What does it correspond with on the new one? QR, which is 6. So remember, scale factor, you can do the new over the old, which is the simplest way to do it. What is the new length? 6, and the old length is 4. This reduces to 3/2, 3 over 2. Or you could do the math way that's also correct. Questions on the scale factor? Okay, we're going to list all the congruent angles. So angle K, what is angle K congruent to? Angle Q. So you can use this statement. Oh, sorry, that's not the statement. You can use this statement, or you can look at the picture in some cases. But K is congruent to angle Q. What else? Angle J is congruent to angle P, and angle L is congruent to angle R. This is again because the corresponding angles are congruent, but the corresponding sides are not congruent. They are proportional. So what we're going to do with them is write the ratios. What does a ratio look like? You can have a colon, that's option 1. What's another way a ratio looks like? A fraction, which is the way we wrote it in the last slide. So we're going to write the fractions of the corresponding side lengths in a statement of proportionality. So we're going to write that the sides are proportional. How many sides are in each of these? 3. So we'll have 3 fractions showing that the side lengths are proportional. Pick a side, any side. KL corresponds with QR. So KL is in the numerator. We need to pick another side from that shape. So pick another one. KJ sounds good. Which corresponds with QP. So KJ, QP. And then last, JL corresponds with, correct, PR. So that is the statement of proportionality. Boom, boom, boom. You're going to do the next question, and then we will check it. We are almost done, just so you know. Yeah, we're almost finished. Bless you. Give you another 30 seconds or so. Then you can check your answer. We'll do this last one together. All right, so what'd you get for your scale factor? 3/5. That's good. And then your angles, you can use the statement. This is a similarity statement. R is congruent to X, S is congruent to Y, T is congruent to Z. And then a statement of proportionality I figured we could do together again. What side length did most of you start with? RT. So if you said RT, what corresponds with RT? X. XZ. What side did you pick next? RS, which corresponds with XY. And then last is TS, which corresponds with ZY. So everyone will have a couple different answers. I'm pretty sure what I do on the test, is I actually leave a fill in the blank because reading all the different ways that you could answer is too much time that I don't want to spend. Questions on this? Perfect. Go to the next page. So we're going to decide if things are similar. In order to do that, your angles need to be congruent. So I don't know why it doesn't say that, but the angles should be congruent. But the sides should not be congruent. What should the sides be? Proportional. That's the blank. Proportional. Essentially, you can figure out the scale factor of each of them, each side, and see if they are the same. This first one is really, really easy because what does AB correspond with on the other triangle? Yeah, XY, right? So what scale factor had to be used to go from 10 to 5? Not 2, a half. So check if all the other sides are a half. 12 became 6, that's a half. 14 became 7, that's a half. So are the sides proportional? Yes, they all were multiplied times a half. And then the angles, the corresponding angles are congruent. These are congruent. These are congruent. You can see that. So if they are, we're going to write a similarity statement, which just says triangle blah blah is similar to triangle blah blah. So let's name the first triangle. What do we want to name it? ABC sounds good. Is similar, so you put a squiggle, to triangle. Correct. X, Y, Z. You write the corresponding parts in order. This next one is a parallelogram. You know how we went to chapter 8 before chapter 7? You would have learned about this in chapter 7, so you wouldn't have necessarily this question. But just for you to know, does anybody know how many degrees fit inside of a quadrilateral?
360.
It's 360, yeah. And what you don't know yet is the angles next to each other in a parallelogram. So think 360. What is half of 360? 180. So the angles next to each other will be supplementary. So this would be 80, this would be 100, this would be 80, this would be 100, this would be 80. You don't know that yet, and it's okay that you don't. You wouldn't have necessarily a question like this. But the reason I said this is that's how you figure out which angles are corresponding to each other and which sides are corresponding. Well, one way at least. So let's start with 5. What does 5 correspond with on the other? 16. So you can figure out the scale factor by putting the new over the old. So the scale factor would be 16 over 5, new over old. Does that reduce? It does not. We want to see if it's the same as the scale factor for the other sides. So what is we have 6 and 24, which hopefully you can see the scale factor. But what is the new length if you go from left to right? 6 became 24. So what's the new length? Well, the new length is 24, and the old length was 6. That reduces to, yeah, so the scale factor is 4. Do they have the same scale factor? They do not. So are these two similar? They are not. This is a no. This one you can probably figure out. Similar means they're the same shape, different sizes. Are these two the same shape, different size? They are not. So no. The angles would have to be congruent, the corresponding angles, and that's just not going to happen here. Number 4, are they the same shape, different sizes? No. The angles aren't the same. One's a rectangle, one's a rhombus. All right, this next one, let's pick our side lengths. Let's start with 12. What does 12 correspond with on the other shape? 21. So let's find the scale factor. You put the new length, which is 21, over 12. What does this reduce to? Divide by 3, it's 7 over 4, yeah? We want to see if that's the same as the scale factor. The only other number given is 35. What does 35 correspond with on the first triangle? 20. So the new length is 35. The old length is 20. What does this reduce to? 7/4. So are they the same? So these are similar. Okay. So we're going to write a similarity statement. Do we want to say ABC again? Triangle ABC is similar. What does A correspond with? K, M, and then N. All right, good. Number 6, they're both rectangles, so the angles are congruent. What does 4 correspond with on the other rectangle? 4. So what would the scale factor be? It would be 1. Is the scale factor the same for 9 and 6? No. This is a no. Questions on this? Okay. We will do one more and then we'll be done. Is this on the next page or the same page? Next page. So these two shapes are similar. We're going to find the value of x. It is a length. What do we know about side lengths with similar figures? They're proportional. So we're going to set up a proportion. Okay, so the triangles are similar, so the corresponding side lengths are proportional. We're going to write a proportion. So the reason that we do this statement of proportionality where we have like 3 fractions, you remember, with all the letters and things, is because you can then use lengths to figure out a missing length. So here's what that looks like. We're only going to use 2 sides just to make our life easier. But go ahead and pick a side from this first shape. Let's pick the letters first. ED. So ED, what does ED correspond with on the second figure? An M. All right, we're going to pick another side length. We do want to find x eventually, so we're going to use x here, which is EF. What does EF correspond with? NP. So what we're going to do is fill in those lengths, and then we're going to solve the proportion. Because the side lengths are proportional, we can solve our proportion. What's the length of ED? 15. And the length of NM? 18. It is proportional to EF over NP. So EF is x and NP is 30. There are a few ways to solve a proportion. What will work every single time is cross-multiplying. I'll show you a second way you could do this one. But you could cross-multiply, which would mean 18 times x, which is 18x. And it would equal 15 times 30, which is 450, pretty sure. Yep. Divide by 18, and x is a number. One of you have your calculator out? It's what? 25. So this is how you solve a proportion in general. Because x was in the numerator, you technically could have shortened this. What's happening to x? It's being divided by 30. So technically you could multiply both sides by 30, but you would need to be confident in multiplying a whole number by a fraction. But both ways are correct. In this class, like when I'm solving problems, will cross-multiply and solve from there. All right, we will do one more, and then we're done. Ignore that, because that's all that. We're just going to do the one on the left first. You don't have to write the letters. You could just use the numbers. You can skip that step if you want. Would you like to write the letters first, or do you just want to get to the numbers? The numbers is fine. All right, so we definitely want to use x. Our whole goal is to find x. What does x correspond with on the other shape? 4. BC corresponds with RS, so 4. They are proportional, so we're going to use this. Technically, use your brain, honestly, but it's fine. Pick a side from the same shape that x came from. 10, which corresponds with 5. Cross multiply, you have 5x equals 40. Divide by 5, and x is 8. This one you could have figured out in your head. You are honors, so there aren't many that you're going to be able to do in your head. But how did we already know that it was going to be 8? What's the scale factor from the larger to the smaller? From the larger to the smaller is 1/2, and then the other way is 2. So you can do 4 times 2, which is 8. But either way, you can put that away.